Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 12th grade topic, finding your recursive formula for your geometric sequence. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So you let's skip ahead to whatever part of the video you think is most interesting. However, if you have any questions about what we see today, or even on homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me about it there. At the end of this video, I'll be linking my 12th grade playlist in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is only going to have 2 parts, so leave a like, smash subscribe, and let's get started. Today we're going to be finding our recursive formula for our geometric sequence. And last week we found the explicit formula for our geometric sequence and noted that the method was pretty much the same thing that we had to do to find our explicit formula for our arithmetic sequence. And you may not be surprised, but finding the recursive formula is going to feel just the same as how we did our recursive formula for our arithmetic sequence as well. Now, if you missed my previous video on how to find the explicit formula for your geometric sequence, or you need a refresher on how to find the recursive formula for your arithmetic sequence, no worries, you can find them both right up here. But we're going to jump straight into this example for today and see how it's very similar to what we had to do for our arithmetic sequence. So notice we're given an arbitrary nth term, in this case our 5th term of our geometric sequence, a sub 5. And that's going to be negative 512. And we're also given our common ratio, which is going to be a negative 4. We're going to use that to find our recursive formula. Now let's start with the general form of our recursive formula. Notice that it looks pretty much the same. We had our 2 parts. A sub 1 is going to be some number k, and we had a sub n equals a sub n minus 1 times your r, your common ratio. And we're writing this so we have, 1, good practice, so we know which formula we're using. We know not to get confused with our 2 different formulas, or 4 if you're talking about both sequences, and also to give us a roadmap to know what we're trying to find for our question here. You notice we only are missing this k. We have our r, and we don't need to do anything to these a sub 1, a sub n, and a sub n minus 1. In order to fill this out, the only thing we're missing is our initial term of our sequence, our a sub 1, which is going to be k in this case. So how do we go about solving for our a sub 1? Well, just like we did for our explicit formula, let's start with our explicit formula. So that's going to be our a sub n equals a sub 1 times our r to the n minus 1. And we're starting here because this is the formula that has an a sub 1, which we need, and it has an arbitrary nth term, which in this case, we're going to substitute our n being 5 because we have an a sub 5 here. So let's plug in our n equaling 5 and see what we get. So a sub 5 is going to be a negative 512 equals a sub 1 times, we know what r is, it's going to be a negative 4, and minus 1 is going to be to the 4th power. So just like you use your explicit formula to find your explicit formula, notice we're using our explicit formula to find a recursive formula as well. So if you expand this out, you're going to have a negative 512 equals a sub 1 times a positive 256. Divide both sides by 256. And when we do that, we're going to get an a sub 1 is going to equal a negative 2. So using our explicit formula, we found our initial term of our sequence is going to be a negative 2. We can now simply plug this in. We know what that k was. It's going to be negative 2. We also know what our r is. That's going to be a negative 4. And if we did that, this is going to be our answer, our recursive formula for this geometric sequence. And you can use this to find any n in your sequence now. But let's jump into one more example just to get a little bit more practice, drive this point home just a tad bit more. In this example, we have an nth term, in this case, an 8th term of our sequence, and that's going to be 839,808, and we know our common ratio to be 6. So we want to find our recursive formula for this geometric sequence. first starting with our general form. We have our a sub 1 is going to equal some number k. A sub n equals a sub n minus 1 times your r, your common ratio. Just like in our previous example, we're going to start with our explicit formula. A sub n equals a sub 1 times r to the n minus 1 power. We know in this case n is going to equal 8 because we have an a sub 8 here. So we know that we can write this as 839,808 equals a sub 1 times, we have a 6 to the, put that in parentheses just for practice sake, to the 8 minus 1 7th power. And if we were to expand all this out, we would have 839,808 equals a sub 1 times 279,936. Divide both sides by 279,936, and we're going to get the following. A sub 1 equals 3. Our initial term for this geometric sequence is just going to be 3. So let's plug that in to our general form of our recursive formula over here. So a sub 1 is going to be 3. And we know our common ratio to be 6. So we can write that here as well. And this is going to be the answer to this question. This is our recursive formula for this geometric sequence. A sub 1 equals 3. We have an a sub n equals a sub n minus 1 times 6, which would be your common ratio. So I hope you were able to follow along with today's video. And I hope you now understand that whether you have your geometric sequence or your arithmetic sequence, it doesn't really matter. If you're trying to find your formulas, the process should be relatively the same. However, if you have any questions about what you saw today or even your own homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so, make sure you hit that like. It really helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I really hope you help with your homework. I'm looking forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Sempai.